Hello everybody. This week 11. Previous we talked about the game series, and we use the tool of game series to analyze the situations where there exist strategic interactions among agents and models. And now we want to turn to another topic: risks. So far, we have been implicitly assuming that we know everything. Everything is certain. Clearly, this is not correct in terms of in our real lives. We do not know everything for sure. So, in this case, we have risks. When we are confronted with risks when making decisions. So we want to know how to handle these situations now. Okay, before we get started, two jargons. Risks. Risks refers to a situation in which possible future events can be defined and probability assigned. So even though we don't know tomorrow's weather, but we know that even though we don't know tomorrow's weather for sure, but we know that tomorrow's weather could be a sunshine day, could be rainy days. So we can assign a probability to this. Maybe we assign 50% to sunshine day, 50% to rainy days. So we can assign probability. That's very important. That's what we call risks. Okay, since we can assign probability to this uncertain event, then very important implication here is that we can ensure it. Okay, sometimes we have another term, uncertainty. Uncertainty refers to situations in which there is no viable methods of assigning probabilities to future random events. Okay, so now when we talk about uncertainty, rigorously, we mean that we cannot assign any probability to this random event. And the implication of this is that we cannot ensure any uncertainty. Okay, so that's the difference between risk and uncertainty. But in many cases, we are going to in a sense, kind of mix it up. When we say uncertainty, we more or less means risks. Okay. Why we have risks in managing firms? Source of risks include different aspects. It could come from general economic conditions. So, and our economies can have boom and busts, up and downs, business cycles. It could be due to industry-wide fluctuation. Could be due to your competitors. Could be due to your technological progress, such that your firm's technology become obsolete. It could come from consumption side. Consumer change taste, so they don't want they don't prefer your product anymore. It could come from process of factors of production, like materials, oil price increases, labor wages increases, etc. Okay, when we describe random events, we use probability to describe it. What is a probability? Probability is an expression of the chance that a particular event will occur. By definition, sum of probability of all events is equal to 1. Okay, so any random events, they have a probability distributions which describes in percentage terms the chances of all possible occurrence. Let's look at examples. Suppose next year your firm's cash inflow, next year it could be $3,000, and which has a probability of 10%, 10% chance of happening. It could be $4,000 with a probability of 20%, $5,000 with probability 40%, $6,000 with a probability 20%, and $7,000 with a probability 10%. So now your cash flow, next year's cash flow could be in 1, 2, 3, 4, 5. Could be could be 5 scenarios. Each scenario has a certain probability. So we describe this random event of cash inflow and the probability using probability distribution. We care about two things here. First thing is we care about expected value. It is the average. So what is the expected value of your firm's next year's cash inflow? So you care about expected value. It is the average of all possible outcomes weighted by their respective probabilities. So that's the formula here. So R is the random event, and in our previous cases here is the cash inflow. And P is the associated probability of that R happening. So now we weighted R by P, then sum up over all possible outcomes. So that we call it expected value. So that's the first thing we care about, expected value. Second one, we care about standard deviation. Actually, we use standard deviation to capture the risks. Okay, the standard deviations reflects the variation of possible outcomes from the average. That's the formula here. Okay, how to understand this formula? So here R bar is the average. R minus R bar. So it's a deviation from the average. And certainly deviation could be positive deviation or could be negative deviation. So and here we square them. So we get rid of the negative sign. And then weighted this square by the probability, then sum them up. Then since we square here, so we want to take a square root. So that's why we call it standard deviation. We actually use this to capture the risk. The higher the standard deviation, the higher risks we are going to say. Okay, let me switch to an Excel of the example. That's the example we have there. So now, this is the example we see previously. Your cash flow, next year's cash flow could be $3,000 with 10% chance, $4,000, 20, so on and so forth. So now, what we can do is we can weight this cash flow by probability. So that's equal to A2 multiplied by B2. So that's the weight. And then you can get the expected value. So it's a sum of the weighted probability weighted cash inflow. So just let me enter the formula here. Sum here. So your expected cash inflow next year is $44,000. Okay, then what's the risk? What's the associated risk with your cash inflow next year? So let's calculate standard deviation. Okay, standard deviation is, let me first calculate deviation. So now what we want to find is what's the deviation of this one? What's the deviation of this one from this one? 3,000 is a deviation of negative 1,400 from its mean. So it's equal to A2 minus its mean. Okay, now I'm going to refer C7. The mean is C7. So I'm going to use dollar to fix it. Fix the reference. C, $7. Okay, so that's a deviation of 3,000 has a negative 1,400 deviation from its mean. Then I can pull down. 4,000 has a negative 400 deviation from its mean. This one has a positive, this one has a positive, this one has positive. Okay, let's say square them. We want to square this deviation. Square deviation. Square. such that we get rid of the negative sign. So it's equal to d2 square 2 square m. Okay. Then I want to weight it. Let me weight this one, so let's weight it with the probability. So that's B2 multiplied by E2. Okay, this one. Okay, let's sum up then. We call this variance. And now we want to calculate standard deviation. Just square root. So it's f7 square root. Okay, so that's 1141.93. So that's the associated risk. That's the standard deviation of your firm's next year's cash inflow. Okay. So that's the standard deviation. That's two indicators we look at: expectation and standard deviation, which we use standard deviation to capture risks. And making decisions involving risks, we usually use decision trees to help us to make the decision. So it is a method for evaluating project risks used with sequential decision making, in which a diagram points out graphically the order in which decisions must be made and compare the value of the various actions that can be taken. Okay, later we are going to look at an example to see what it is. A decision tree is composed of decision points. They are designated with squares on the decision tree and chance events, which we use circles to denote them and assign probabilities to this chance event. Okay, the step we can follow in making the decisions involving risk is first convert all flows into present value if your project involves time dimensions. Set up all the branches of the decision trees, move back from right to left, or from backward. It's kind of backward calculation. Calculating the expected value of each branch, eliminate branches corresponding to poor decisions, which is negative present values or losses. Then compare the net expected value of the final remaining alternatives to arrive at the solution. Let's look at an example. Okay, suppose you are a manager of a property, and certainly you are not God, so you cannot control weather. Okay. But fortunately, you know that next year's weather could be too tight. So now next year's weather is a random event, and it has two outcomes, two possible outcomes. First one, it could be a wet year, or it could be dry years. But you don't know the weather, next year's weather for sure. And for you as a managers, you have two alternate strategies. You can do two things. First one is you can either plant rice. Clearly, if you plant rice need water, a lot of water, so wet year will be good. Or you can graze camels. Camels, they are pretty good with drought. So if you graze camel, and then the year is dry wet years, then it's good. Okay, the outcome of the manager's strategy certainly, as we see, will depend upon the state of nature, next year's weather. So if you plant rice, it turns out to be a dry years, then you are going to make loss. And if it is wet years, you can make big profit. Okay, if however you keep graze camels and the weather turns out to be dry years, then you can make big profit. If it turns out to be wet years, then you're going to cry. Okay, and you can set up decision trees here, starting from this point. So you have two strategies: plant rice or graze camels. So if you plant rice and weather turns out to be wet, then you can make $4 million profit. If you plant rice, then weather turns out to be dry, then you can make $1 million loss, negative $1 million. If you graze camels and weather turns out to be wet, then you can have 40 million loss. You can calculate this based on your knowledge, your previous knowledge. Dry, 10 million profit. Okay, so that's your decision trees. Okay, so now you want to calculate, because you got to choose between rice and camels. So you want to calculate the expected value of planting rice and the expected value of planting camel, and the associated risk. Okay. Let's look at the camel first, and I'm going to turn to the Excel. So let's look at camel first. So the profit, you can possible profit you can make, probability. So grazing camel, if the weather is wet, you make 40 million loss, and if weather is dry, you make 10 million profit. Okay, and now you want to assign the probability of wet weather and probability of dry year. And what you can do is you can go to the bureaus to check the past, what happened in the last 100 years or whatever, you know. You can work out an empirical probability of this. So this suppose is 0.2, 20% of wet year, and that means 80%, 0.8, 80% of dry year. And know that you got to sum up to 1 by the construction, by the definition of probability. Okay, so let's calculate expected value, expected profit of grazing camels. So now we want to weight this profit by its probability. So that's B3 multiplied by A3. Okay. Okay, I'm going to just, here's R, suppose that's R is profit multiplied by probability. Okay, the expected value, Sum them up. So expected value, expected profit, let me call it, expected profit is 0. Okay, let's say, so now we want to calculate the deviation of negative 40 from its mean. So that first one, we got the expected value. We need to calculate the associated risk as well. That's standard deviation. So that's bar. Let's see. So it's equal to this one take away 0. So that's A3 take away the expected value is C5, and I'm going to fix the reference. Yeah. So that's it. Okay. Let me call it deviation. And I'm going to square the deviation. That's the formula of the standard deviation. The D3 square m 1600. Then probability, weighted by probability. So that's equal to probability is B3 multiplied by E3. Then sum them up. And we call this variance. Sum them up. Then standard deviation, which is the square root of the variance. So that's F5. So it's 20. So the risk associated with a grazing camel is 20. Okay, so that's camel. And let's look at rice. Similarly, if you plant rice and it turns out to be wet year, then you can make 4 million profit. Okay, I'm going to use 4 million. 4 million profit. And if it is dry year, is 1 million loss. Okay, and I'm going to just paste the formula into here. Paste formula. So weighted this one by its probability, you get the expected value, which is sum of this one, still 0. And then you calculate the variance. So you calculate deviation from its mean, then square them, then weighted this deviation by probability, then add them up, you get variance. Square root, you get this. So now that's your calculation here. If you graze camels, the expected profit is 0. If you plant rice, the expected profit is 0 as well. So both strategies have the same expected profit, but risk are different. If you graze camels, the risk is much higher. It's 20 than planting rice, which is 2. Okay, so now should you graze camel, plant rice? The answer depends on your risk attitude. So if you are risk neutral, then you don't care. Both options are fine, exactly the same for you. If you don't like risk, you are risk aversion. You have risk aversion, then clearly rice is better option for you because the risk associated with rice is smaller. If you happen to be risk loving, then grazing camel will be a better option for you because it has a higher level of risks. Okay, so that's all about handling risks, incorporating risk and decision making. So I'll see you next week.